Now we find the Laplace of t raised to the power n. So by the definition we know that Laplace of f is equal to 0 to infinity e raised to the power minus st. And what is f of t? Here f of t is t raised to the power n and dt. So by the integration by parts, e raised to the power minus st, e raised to the power minus st minus s, t raised to the power n, and minus this one is minus and minus 1 over s, e raised to the power minus st, and the derivative of n t raised to the power n minus 1 dt. So here the limit is 0 to 0 to h for the improper integral, and limit h approaches to infinity. It is also 0 to h. So of course when we put h over here, limit h approaches to infinity, it will be e raised to the power minus sh and h raised to the power n over s plus, and then what we get here, when we put 0 over here, then it will be t raised to the power, since we are putting it over t, so it will be t raised to the power e1, it will be zero. It will be because so plus 1 over s, and 0 to if I write here, it was infinity plus 0 to infinity e raised to the minus st, and I am writing n over here, this is t raised to the power n minus 1 and dt. So when we put h over here, of course we get infinity. So by applying the L'Hopital rule, after applying the L'Hopital rule on this term, it will convert into 0. So it is again n by s, and it can be written as by the definition of Laplace transformation. It can again written as, this is the Laplace of t raised to the power n minus 1. So what is the Laplace of f? Laplace of t raised to the power n, Laplace of t raised to the power n is equal to this one. Now I am writing again, if Laplace of t raised to the power n, is equal to n by s Laplace of t raised to the power n minus 1. So it means that Laplace of after successive applications, Laplace of it will again equal to n by s. When we find the Laplace of t raised to the power n minus 1, it will be n minus 1 over s, and Laplace of t raised to the power n minus 2. So again n minus 1 over s. When we find the Laplace of this function t raised to the power n minus 1, it will be n minus 2 over s, and the Laplace of t raised to the power n minus 3. So after finding by n minus 1 over s, n minus 2 over s, and up to so on, finding the Laplace each time t raised to the power of t is decreasing. So finally we will get the Laplace of 1. So which is 1 n by s, and n minus 1 by s, n minus 2 by s, up to so on, which is 1 over s. So this is n minus 1, n minus 2 can be written as n factorial, and we know if I write this, up, this is Sn, and this one is n plus 1. So I can write Laplace of t raised to the power n is equal to, this is equal to n factorial over s raised to the power n plus 1. Thank you.